And let's jump into our next speakers, who are from Switzerland, which is, as you all know, not the same as Sweden, but we are quite similar and equally brilliant. So say hello to Alexis and Christophe. And I know Alexis has a little bit of a slow voice today, so I think Christophe will do most of the talking. That was how it was presented. So let's see how they thought out that.
So exactly, that will be. I'm sorry about my voice sound. So that will be Christophe. That will be doing most of the presentation. So first of all, I would like to thank you for having us. It's a real pleasure and very interesting presentations, and to exchange on that. So I will present you a little bit Bridgology. So we are a company that was that I created 7 years ago. We are specialized in ground penetrating radar, as was presented by the first speaker. And our role is to analyze this data and to get most of the information possible. So we include ourselves in predictive maintenance of structures. And what we do is that we use our results to plan ahead for the degradation of the infrastructures. I will now let Christophe do the rest of the talking, and I wish you a very nice presentation.
Thank you.
So, thank you, Alexis. I will take over. As Alexis said, we are working with GPA technology, and we provide our customer clear and synthetic visualization tools for their infrastructure. And our goal is really to help our customers prioritize interventions and minimize cost and duration of maintenance on the infrastructure. We have a workflow that is optimized for concrete bridges and viaducts, but we are active in the domain of retaining walls, tunnels, and as well as the preservation of the historic masonry. The first speaker talked about the GPA, and in our case, so this is a non-destructive testing method that is based on the propagation of electromagnetic waves, and we are able to detect the different layers and the different elements within the concrete or masonry structure. And our main added value is computation of conductivity, which is how the waves are affected by the presence of ions in the solution, in the water, in the concrete. And in our case, it's an indication of the chlorides content, which is causing the corrosion of rebars in the concrete. And this is our main output for the customers. We provide, on top of a 3D LiDAR map, we provide different layers of information, as for example, the asphalt thickness, in the case of a bridge, asphalt thickness, and the cover concrete thickness map. And we can directly identify areas with too many, too little, and areas with problems. We also give information about the waterproofing condition on the bridge. And we can also detect mechanical disorder within the concrete, so under the asphalt layer. Then we output contamination map. This is the beautiful colorful map here. And we can see the total contamination within the concrete. But this is not enough information. The most important is the corrosion risk map that takes into account the level of contamination and the thickness of the cover concrete. And this gives you an indication of the health of your structure. So our method is to do a basic non-destructive measurements during the night with partial disruption. And after about a week of work, we can output a report that provides all these data to either the engineers or the bridge owner, so that it can plan accordingly the repairs or not, and also have a better estimation of the cost and duration of work ahead. And this is very important when you have a number of bridges in a row on the highway. And we are able to scan 10 bridges, and you can say which one is the worst, which one is the best, and you can prioritize your intervention in that way. And I will present now 3 examples. The first one is Highway Bridge in Switzerland. These are twin bridge, so 2 different decks, and the bottom one seems to be in a good condition, but the top one has a much higher concentration of contamination. And the engineer started to do a window at the bottom bridge and didn't reveal any corrosion or anything. But after we did the scan, we told him, like, maybe take a second look on the top bridge, because this might be, you might find more corrosion there. And when we look at the corrosion risk map, we see a clear pattern emerging from the deck, that having 2 lines that are high potential risk of corrosions. And this was partially due to a very small thickness of concrete and some kind of recess in the concrete that caused water to stay and contaminate the area. And this was just above a pre-stressing cable that runs in the bridge. And after the second inspection, we revealed some really high amount of chloride content, or very high risk of corrosion within the bridge. And this could have, the engineer with his first initial inspection could have not seen it at all. So thanks to our method, we reveal a big problem on the bridge, and further inspection will be done on the bridge. We are also working with tunnels. We do a series of longitudinal profiles along the cladding of the bridge. And in that case, we were supposed to measure the thickness of the different layers, and also trying to localize problems with the water that was getting inside the tunnel. And making a new concrete surface is not enough. We need to find the problem and where is this water coming from. So thanks to our analysis, we located the entry source of the water at the beginning of the tunnel, and we've related that to the change in the geological layers on top of the tunnel. And we were able to provide the engineer with a clear localization of where the water was coming from, and then they could get the proper solution to fix the water intake. And the last example, that is a beautiful bridge in Geneva, Switzerland. And that's a masonry bridge that had a faulty waterproofing layer. And what you do in that kind of case is that you close the bridge, you take all the pavement away, and then you go into the arch and you try to see what's going on. In that case, they ask us to determine and count the disorder within the bridge. And that was mostly in terms of cracks and voids within the vaults. And they wanted us to estimate the filling volumes, for then they would fill the voids with cement to ensure the stability of the masonry. This was done with the numerous amount of GPR profile over nights that were taken from the top and bottom of the bridge, and we output them 3D mapping of the vaults with all, as you can see, all the voids within the masonry. And the added value in that case, that we were able to provide the engineer with a precise plan for targeted injection of cement. All the points you see here are areas where they injected cement to fill the voids, and each colors represent a different depth of filling. So they could go and fill exactly what amount was needed and exactly where it was needed. So there was no loss of cement, and the objective of 75% of the void reduction was achieved with almost 80% in the end. And we came again to scan the bridge and see the final results of the leftover voids in the structure. This was extremely effective intervention, and that was within the deadlines for the for the intervention, and there was very disturbance with the traffic with that method. As we also do everything that is related with GPR. We also locate pipes within the before construction or when they do renovation. But our most added value is this conductivity measurements and the estimation of the risk of corrosion. And this really help bridge owners. We work a lot with bridge owners in Switzerland and engineering office to provide them with a really clear view of their structures before they do any kind of repair.
Exactly.
If you have any question, happy to answer.
Brilliant, Christophe. It's really great.
Thanks.
And Alexis, you did very well as well.
Thank you very much.
So I have a couple of questions for you while on the topic here. How deep into the structure material can you measure, and can the same solution be used to check status of buildings?
So maybe I can answer that as well. So we can it depends of the type of antennas we are using. So you have different types of GPR antennas. The one we are using is going generally between half a meter to 1 meter depth. There are other types of antennas that can go deeper, up to 3 to 5 meters, but these are not used for building inspections or for structure inspections. So yes, we are also inspecting buildings, historical buildings in masonry or also in concrete. The applications can be done on parkings, on retaining walls, on every concrete structure or masonry structure that is of interest. The goal is, the key thing is to see us really as radiologists that are highlighting every defect or problem that might be related either to mechanical disorders or to chemical disorders inside the structures.
Great. I have another question for you. Who is the typical customer, the city or the entrepreneurs? Is it primarily used for screening or to prepare for repair? This comes from a city, so I understand the question.
So, okay, generally it's city owners, city managers, bridge managers from cities, from the Swiss Federal Road Office, Highways England, Transport of Scotland. So it's generally big bridge owners that are contacting us for park management. So it really takes all this power when you are inspecting a set of structures. So as Christophe said, 10 to 20 structures in a row to manage the priority of intervention. And
Perfect.
Okay, I just want to,
Yeah.
one last point. We did not mention that, but we are also using some fiber reinforced concrete of very high performance to repair. So it's not only that we are targeting the defects, but we have also solutions for the repair if needed. Thank you, Magnus.
Brilliant. Thank you, Alexis.